Hello everyone, welcome to this tutorial where we are going to learn how to use tracker software. Okay, so if I go down here, I can type in tracker. Look at that, there it is. Click, it's popping up. It is a good day. Okay, next, video, import. So you made a video, I made a video. And we're going to use this program on these computers to track it. First thing, a coordinate. So a coordinate system, or axes, sorry. We're going to put this down here. And that's just telling the program that this is horizontal, this is vertical, etc. Okay? I'm now going to just click that again so that it's off. Next, new calibration stick. So we want that. So this says 1 meter. I'm going to line that up with my meter stick. Oh, that looks good. And then if yours does not say 1 meter, you can type that in there and turn it into a meter. Okay. Things are really happening. Okay, the video does not really have any action until we get to way over here. Tiny bit more. Okay. And likewise here, I can scroll this back. That's where that goes. Okay. And if I click over here, it brings my slider to the start. Okay. Okay, next, I'm going to click on track, and I want a new point mass. And look at that, it is going to make some graphs for me. So now I'm going to track the ball's motion through its arc. So I want to try to click on the same part of the ball the entire time. But look at this. This thing has been stretched. This is not some special relativity going on. This is just, yeah, it's I don't know what this thing's shooting at 60 frames per second, maybe less. But I'm going to do my best to click on it the same place every time. So I'm just going to hold shift down the entire time, and then I get this target. So I'm going to put the target on the top, boom, and it moves it to the next frame. Same spot every time. Oh yeah. And you would do this much more carefully and spend more time. And you may notice, oh, I'm not doing a very good job, but I know you will. You may notice I'm getting graphs produced on the right. It is doing it for me. Okay, now the ball's getting stretched a bit again, but I want to do my best to try pick the same spot every time. And I'm trying to aim for where I think the top of the ball is. Okay. Okay, so I've tracked its position and I've got graphs. So I'm going to make these graphs a little bit bigger. And I actually only want to plot one at a time. Okay, so if I go on plots, I can do that. Also, I just want a graph. Okay, now there are 4 graphs you have to make. One is velocity in the x, velocity in the y, and then you also need a velocity or an acceleration in the x and an acceleration in the y. So this is just x meters. So this is position in the x. I'm going to go click on that and go Vx. Whoa. Okay, what is happening there? Well, here's 2.60 meters per second. This is 2.65 meters per second. That's like a tiny, tiny bit different. And so we want the best representation of this data. And so I can do that. If I go to the top right here, I can move this up or down. And this is a whole lot better than it was before. Okay, this is a more accurate, useful representation of the data. Okay, in the X direction, it is simply just moving to the right. And I know there's some variation. And some of that is simply due to my poor clicking. Okay, so next what I want to do is I'm going to actually rename this. So if I click on track and mass A, I can name this. I'm going to name it horizontal velocity versus time. There we go. Okay, and now once I'm happy with my graph, I'm going to go right click, copy image, and you can put it into, let's see here. So here's, oh dear, right over here is my lab. I'm going to first paste it. PowerPoint is way better. I'm going to paste it into here because what I want to do now is I want to actually have a line of best fit. Okay, so I can go like this. That is pretty good. I think right there. That's a good line of best fit. And I'm going to make that red and slightly more bulky. Okay, I like that. This is some good data. Next, I want to put this into my lab. A nice easy way to do that, you can hit the Windows sign on your keyboard and Shift and S. And look, I can just make a screenshot. Windows, Shift, S. Now it's made a clip of that. And I can't actually, because of my program here, I can't get to my lab. But that now you can just paste that into your lab. You'll be able to do that. And you've got a beautiful graph with a line of best fit. Okay, so if I want to make a vertical velocity graph now, I don't have to redo this. I can just go to Vy. Or if I want to do an acceleration graph, AX. But same thing, you want to find the best representation of the data. Okay, and you are going to have to take a look at your axes and think, okay, what is the best representation of my data? Okay, now a quick hint, your acceleration graphs are going to be really bumpy because they are being derived from this. It's taking the slope, taking the slope, taking the slope, and it's making an acceleration graph. And so the more bumpy that your velocity graph is, that is actually exaggerated in your acceleration graphs. So your acceleration graphs aren't going to be as nice as your velocity graphs, but you should still be able to find a good representation of the data. So I hope that is helpful and makes sense. You're going to do great work. All right, see ya.